This is my first time experiencing the Microchip Masters. Our team and our CTO was here last year for the first time and said, hey, Ali, you've got to come. This is an amazing energy. There's a lot of innovation, a lot of smart people coming in one place and trading ideas and thoughts. So I decided to come, and I was so happy to be here and get an opportunity to speak to you all. The topic that I'll be talking about is in the industrial IoT space. But before I get into that, I kind of just wanted to give you a little insight on who we are as a company. I'm not sure if a lot of you know who SenRa is. We're a 2-year-old company, but we are rapidly deploying infrastructure across India to support innovation and deployments of LoRaWAN technology, wide area networks. And we are currently deploying, focused in, we started in 2017 in the Delhi NCR area, covering about 16 million people with just 4 gateways. So we were talking about population, and that was a big success for us. Actually, being the co-chair of the marketing committee of the Alliance, we were discussing on how to demonstrate the amount of coverage, the global presence of LoRaWAN is, and some of that was around population versus coverage of area. The LoRaWAN technology, why I decided to invest in that is I thought it was the de facto standard for LPWAN technologies within the world. The Alliance established in 2015, brought some of the leaders of wireless communications onto the team. Our partners in the US Senate were one of the first founders. And then from there, it's been rapidly growing and growing and growing. And these are some of the key advantages that I felt was why I wanted to invest money and bring that technology to India. Some of if I had to look at it, security, long range, battery life, those are things that are being done, but not as well as what LoRaWAN can do. And then the cost associated to the technology. Price sensitivity is something that India needs and is very cautious of. And the fact that we can bring solutions at low cost really gives a competitive advantage over the alternative technologies. If you look at LPWAN benefits, so LPWAN is low power wide area networks. LoRaWAN resides within the LPWAN family. But if you look at it and break it out to LPWAN versus LAN versus cellular technologies, there is keys and positives and negatives to all the technologies. So LoRaWAN isn't suitable for high bandwidth communication, but we believe as an alliance and as a company, SenRa, that 55% of the IoT market is suitable for LPWAN technology and LoRaWAN technology. As I go into the industrial IoT space, you'll see some examples that we've done with Microchip in successful deployments that demonstrate that power. But in the market in India right now, roughly 60% of the market resides in smart city opportunities as well as industrial IoT opportunities. And within that 60%, you're looking at exactly what you see here in the LPWAN, the metering, water, and a lot of things that were mentioned in the previous discussion. And RD, I'm a little shook a little bit. Your presentation was so good, I don't know if I can meet that. But if you're looking for high data throughput, CTCV cameras, all those things, LoRaWAN or LPWAN is not really the place for that. Now, within the LPWAN technologies family, you've got several different protocols. As you guys are learning and developing and taking these workshops, I'm sure LoRaWAN is not the only topic of discussion. You're probably looking at Wi-Fi, Zigbee, NB-IoT, but in the LPWAN phase, what I've done is kind of broken out into metrics to kind of show you what the pros and cons are in all of these different protocols. And really for me, the only negative is the maximum data rate that LoRaWAN can provide. But again, the market that we're going after, 55% of the market, doesn't require the high data throughput. So the great thing is there's an alliance with the standardization. There's 128 AES encryption already on the communication stack. There's ways now that Microchip is even showing, and we'll talk about it later, the secure element piece to make even the device secure. And it's not in a licensed spectrum, so it's unlicensed. Anyone can deploy their own network, private. There's public service providers like us and Tata Communications in India that you can go and get a managed network service for you. So it's very, very flexible to support you. If you guys need to do any R&D or development, you can come onto our portal at SenRa, portal.senraco.io. You can create a free account, you can add free devices, your own gateways, and you can just play without having to ask a telco operator to bring the network to your location. So you can do a lot of this from your home if you wanted to just tinker. So SenRa, we focus in that highlighted area. Our core expertise is network management, RF deployment, and so we'll go deploy the gateways. We have a managed network server and a customer portal that we offer. But as the ecosystem grows in India, we've been finding that the device ecosystem is still coming up. The analytics piece may be there because India is great in software, but the ability to take the data and make sense of it for business decision making is still lagging a little bit. So some of our customers will come to us and say, hey, can you provide end-to-end solutions? And we can as needed. But our core focus is within that middle area. So some of the cool stuff that I love, and we were doing a smart city assessment in a city in India, and it was a pan-city coverage, and I didn't know how powerful our own tools were until I sat down and sat with the network team just to kind of walk through how they do it. We uploaded a CSV file of, I think, 9,000 end nodes that would go into the city. Each one had its own lat long. And then we have relationships with our telcos, infrastructure providers. So we got some sites availabilities from them, and we uploaded that into the system. And next thing I know is we are getting actual real-time RF propagations virtually with our software, and we're able to do planning prior to even sending one person out in the field. Through this exercise, I really appreciated the time that it takes to do the proper network RF planning for a successful project. And I found in several projects that we've done that our software is roughly 97% accurate with what is actually on the ground. So we get a real huge competitive advantage, at least in my opinion, from our competitors. So as I mentioned, we're deploying infrastructure real fast. We're currently in 56 cities as of this week. And by the end of December 31st, we will be in 60 cities in India. And then next year, we're going to go into 100 cities. So we heard a little bit of discussion about the Smart City mission. That's there. They have a 100 city Smart City mission. They're bringing a Smart City mission 2.0 that's going to be announced soon. And that's going to go into 4,000 cities, villages, and other areas that are looking for that digitalization and development. So if you all are looking at where the market opportunity is and why did I come to India, that's one of the driving factors. So now that's enough about SenRa. I want to talk about industrial IoT. The video kind of stole my thunder a little bit on this slide, so I won't go through the timeline. You got to see it in a cool video. What I do want to highlight is the Industry 3 to Industry 4 differences. So my father is an electrical engineer. He's just like you all. He builds boards, he does probing, he does R&D, and Lay's, the chip manufacturer, back in when I was a child, had contracted the company that he worked for to develop a probe that would go into these big, massive containers to give calculations on how they can get the most out of their production within this big barrel. And so he's like, son, what are you doing? What is this IoT thing I hear? What is this, industrial IoT? And I was like, well, Dad, and I walked him through. I was like, we deploy a gateway. He's like, what is a gateway? I was like, it's like a Wi-Fi router. We install that. Okay, then what do? I was like, then we go and take sensors and we deploy them throughout the facility and we send the data wirelessly throughout the facility. He goes, I did that. I was like, what do you mean you did that? He's like, I've been doing that for 30 years. I said, yeah, but Dad, where did the data go? He goes, well, we had a computer right there inside the facility, and the data would end up in that computer, and all of it was localized, and you could log in and check the data. I said, there you go, Dad. That's the difference between 3.0 and 4.0. It's the ability to get away from that facility and to be on vacation in Goa on a beach and open your laptop or your phone and see data of your facility in the production line. The ability to process data rapidly is what the separation is from 3.0 to 4.0. The other thing I want to highlight is from 1.0, 2.0 to 3.0, they were really focused on speed and being able to increase quality of the production. They pretty much mastered that for, if I had to guess, at 3.0. So what does 4.0 do other than remote data transmission into the cloud? It's actually increasing operational efficiencies. They've already got as fast as they can really go. I mean, you can add some robot arms and stuff and it gets a little bit faster, but they're not having the exponential performance increase. So as the timeline goes by, speed is not as important. It's how do you focus on the operational efficiencies that the businesses are looking for in order to save money. And see, these are some global market stuff that I wanted to throw you guys. Usually CEOs throw big numbers and stats, so that's kind of what I wanted to do. The coolest thing is by 2020, you're looking at a $110 billion market. By 2021, it's going up $23 billion US, and the global economy expectations by 2030 in industrial IoT is $14.2 trillion. That's a massive, massive market. If you all are looking to develop solutions, I would strongly look into the industrial IoT space. And this is showing you just up until, I think the statistics were based on 2016 up until 2020. The compound annual growth rate is at a 73% increase every year. So, industrial IoT, as of last year, was the second largest vertical or IoT segment with real commercial deployed projects in the world. The first was smart cities. So you know that those top two, as I mentioned, even India today, we're seeing about 60% of the market share is between those two. What's happening in India is they're expecting 18% of the overall IoT market by 2020 will be industrial IoT. And we've actually looked at it as a cost sensitivity perspective. I mentioned earlier, India's price sensitive. It's price sensitive. There's a lot of investment in equipment and in the manufacturing phase. So we wanted to kind of step back and find a way to address connectivity and smartness without having to invest so much money in new equipment and new hardware. And what we did is, okay, we looked at the statistics and we say, where does that lie? How can we contribute the most with the smartness? And they did a poll on, I believe it was 6,000 business owners within industrial IoT and manufacturing, and they asked what was their biggest thing that they were looking to get out of with IoT within their businesses, and almost 50% said improving operational efficiency. So that's a massive, massive focus that you should be looking at when you're thinking about developing products into the industrial IoT space, is try to address improving operational efficiency. Second to operational efficiency was improving productivity, which has always been a target as far as Industry 1.0 was. So if you can solve those two things, you've addressed about 70% of people's concerns, maybe even 80%. I won't go through each one, but if you're taking pictures, refer to this later, and I'll see if Microchip can make this available for anyone that's interested to be able to go back and refer to. So another thing that was mentioned by Mr. Pai, and even yesterday, if you guys were here on this speaking, the hacker speaker, and the focus of this Microchip Masters, some of it's related to security. This was a stat I found quite interesting. I grabbed it off the internet yesterday. I didn't even know this myself, so I was like, I have to put it on a slide. So you're looking at every 5 minutes, there's an attempt of a hack on a device as soon as it's communicating to the internet. And that's a pretty big deal, especially when you're looking into a manufacturing facility where if they hack a device that controls the power of a big, big piece of equipment, causes the whole factory line to go down. The minutes matter from a productivity and a profitability. What if someone kills a device that's monitoring the temperature of the equipment and then that temperature of that equipment gets so high that the equipment fails and breaks. Now you have to replace it. So those are things that I believe still hasn't been taken seriously, and I'm really pleased as a part I go through these use cases that you'll see some of the security being addressed with collaboration with Microchip. So my vision of the future of industrial IoT is connectivity. So I wrote a white paper for IoT. It has about 30 different use cases across many different segments of IoT. And I started a paragraph, and in there I tried to define what IoT meant. And in me, the ideal IoT is when you have a symbiotic relationship between humans and machines. And this is kind of how that would play into industrial IoT, where you've got connectivity of the machines, you've got connectivity of the people, understanding their health. Are they being overworked? Transmissioning all of that data wirelessly through the air, where it's being managed and monitored on a daily basis in real time, providing historical feedback on productivity, connecting your third-party logistics systems with your warehouses, decreasing the production loss, increasing the efficiencies and productivity output is something where industrial IoT is already headed. So I'll give you a couple of case studies. The first one we did with a very large manufacturer in India. We call this case study vehicle tracking, but it's not the traditional vehicle tracking that you guys are thinking of, and I'll explain why. But this is connected operations. So the requirements of the customer was they have, I think it was like 8 hectares of land in one site, and they've got many, many sites throughout India. And there's not a lot of internet available in that 8 hectares. What they have is about 400 trucks per day come into the facility area, the campus, the grounds, and they stop at different locations. They pick up, they drop off different shipments, and they exit at the end of their process. That process alone takes roughly 3 days per truck. So as the truck is on the ground, that customer has to pay their vendors, these people that are providing the drivers and the trucks, hourly rate on the driver, and it's pretty high. So they're looking at decreasing 3 days down so that they can save some money. Not only that, if they use IoT smartly, they can have the products ready and before the truck even gets to that specific pickup spot. So the challenges I kind of mentioned, they had already invested money. So when I mentioned retrofit solutions, I believe it's going to be huge in industrial IoT's future, is they invested money in RFID already. These RFID have tags. You can actually go to our booth and see it. We've got the devices, and we can show you how it works. But they give a chip about this big to the driver when he comes on. And each of the facilities has an RFID reader. And as the truck pulls in, it sends a signal. Pretty simple, cheap, nice solution, right? Now, that RFID reader backhauls on LAN, an Ethernet plugin. Well, they don't have LAN everywhere on this facility. So they've invested money in this hardware already. They don't want to go and scrap it. They don't want to make it shelfware. So what do they do to make it smart and provide that same data transmission? So they reached out to us. They saw us, I think, at IoT Congress, Kush, in 2017. He's our CTO, by the way. Hi, Kush. So they called us and said, can you solve this problem? And we were like, yeah, I think we can. So what we did is we invented an RS-232 converter that plugged directly into the reader, and it took the data packets and it sent it over LoRaWAN, and all we had to do was deploy one gateway. One gateway covered the entire campus facility, and they were able to now connect all of their readers that they already invested in with a retrofit solution that runs off of, in this case, power was already there, so that wasn't an issue. What they were able to do, as I mentioned that story of 3 days, now, after 4 months, the truck drivers are leaving in 1.5 days. So in 4 months, they've reduced 50% of their transportation costs, and they're moving these drivers out much, much, much faster. I expect this number of savings to go up as they get better at this monitoring process and these alert processes. We thought it was a massive success. So for the techies out there, how did it kind of work? We had the tag, which communicated wirelessly to the RFID reader. The RFID reader, via wire, plugged into the converter. The converter had the MCU, and this is where security came in. We worked with Microchip to put their secure element directly onto the board, and the keys exchange, so the dev UIs, the app UIs, all of that stuff is being exchanged directly on the device. I don't have to ask the customer to email me a zip file of their keys, which could potentially get hacked, and then they can be exploited later. So all of the security was locked down on the device from the beginning, and then it communicated securely at 128 AES encryption wirelessly through our gateway, which then went into our network server, and we just simply routed the data to their application server that they want. So it was a big, big, big success. And these are the initial prototypes. They've now evolved into much, much nicer looking devices. But these were the first ones that we had developed, and we took pictures of it. And you can see kind of where the different wires were plugging in on the grounds and the RX and TX. So the last case study that I'll talk about is automated worker attendance that you're seeing here this week. You're going into and out of your classes. You guys should have seen some standees there that have this automated attendance. That's also helping with connected facilities. So customers want to automate their worker attendance system. It's not to track the employee and to cut their paycheck, which everyone would automatically think of. It's actually a lot more than that. They want to be able to understand in incidental situations or emergency situations where the employees are actually located so they can quickly get them out of danger. And some of these facilities and manufacturers, I spent 12 years in the healthcare and life science, and some of those places are dealing with some really explosive, flammable things. If something explodes in a section of the building and you need to know where your employees are, that's a big, big deal. They get audited to understand that they have these processes implemented in place to protect the employees. So that was the main key driving factor of this solution. You're not only just addressing the emergency response system, but you're improving your payroll process, right? You now know if someone was on leave or not. And you're also addressing their workloads. If someone has been working for 14, 15, 16 hours, their productivity is going to go down. They're going to get exhausted and they're going to make a mistake. And you don't want that when it comes to quality or someone getting hurt. So having this system allows them to be able to assess that. Some of the challenges that they were seeing is legacy systems weren't providing real-time insight. A lot of people are still doing spreadsheets for employee attendance tracking, which is like, how do you know if the guy was in section A of the building or section B of the building? And there were some existing solutions that were trying to be used, but traditional cellular technology doesn't have deep penetration, so it wouldn't work all the time. There was intermittent communication. And they didn't really know how to take this data and implement it into an incidental emergency response system process. So what you see outside is an example of, again, another Microchip and SenRa collaboration where the data is leaving the reader. Again, this also has a secure element on it, going through our gateway, going through the network, securely sending data into an analytics platform that is giving a real-time insight on how many people are coming in and out of different areas of a facility. And I asked you if you have a chance to go take a look at the device that's out there. Everything on LoRaWAN this week that you guys get to play with in your classrooms, that you see outside in these exhibit areas are all connected with our network. And so we're pretty excited to be able to light up this whole campus with just a gateway or two. And as the co-chair of the marketing committee, it's kind of my obligation to talk about the LoRa Alliance a little bit more. So this is my last slide. What I want to do is highlight the growth of the LoRa WAN ecosystem in India specifically. There's a lot more companies doing LoRaWAN. I didn't have enough room on the slide to give everyone a shout out, so forgive me if I missed you. But this is also not external companies bringing LoRaWAN solutions to India. This is India-owned companies that are doing stuff in the LoRaWAN space. And industrial IoT is small right now, but it's rapidly growing, and you guys are all able to contribute to that. So if you're interested in learning more about the LoRa Alliance, you can always email me directly or go to the LoRa Alliance's website. We have seen a major increase in our business by being part of the Alliance and being a member. And you get a lot of benefits networking with other global leaders out there. So I thank you for your time. I know you guys are probably hungry. And if you have any questions about LoRaWAN, I'll be here for the remainder of the evening. But we have a booth. The guys will be here for the following time. So thank you so much for your time.